My name is Wayne Stillwell. I was an Army colonel. I was in General Shinseki's program that brought FA-57 simulation to the Army. You guys might remember in the early 90s we were trying to figure out how to be more effective trainers. We kept running into a few large money expenditure heavy programs, and we weren't managing really well, so we sent a few people to school and tried to do a little bit better. Through that system, we learned a lot about interoperability of simulation, and over time we transitioned from simulation taking directly the mind of a commander or a staff or a trainee in a learning environment to command and control systems of population and using your actual combat system for such effects and events. Well, that transition is also applying to machinery as well. Machinery and robots, and the definitions and terms are a little slippery. Even the term autonomy, if you notice today, autonomy is defined in our RD&E framework more in the idea of an enabler. I think it's closer to capability than enabler. I really do. I think it's revolutionary. I think there are very few topics in technology that are as rapidly game-changing as systems that can work together well as a team. And most technological effort in robotics right now, if you look through the literature and just pay attention to what's being marketed and what's being developed and what's known about, concurrently is about making individual systems better at mimicry, better at what it is they do. There's very little work being done on how to make machines effectively work as a group. So my presentation is very short today. I've got some flyers. My purpose today is twofold. One, I'm looking for industry partners because I think I have some software that works. We're very small, me and a couple of part-time programmers who are students. My company is about getting young people jobs and about revolutionizing team machines. The second part is the first speaker that you just heard, Tom Keeley, and their CEO, Helena Keeley, who's the brains of the outfit. What you just saw is revolutionary, strong stuff. And we use their software to do revolutionary things, and a high schooler programmed it. Forest Park High School, senior. So even though it looks incredibly difficult, just like a cell phone, there's a lot of technology, but the user interface makes it usable down to a lower level. So we take young people because they're not afraid of such things, and they do effective things, and it works really well. If you don't tell them it's hard, because it's not, but it looks a little complex with all the rectangles. I would tell you that if you do anything at this conference, you should learn what Kiel technology can do. And you should get your CTO involved, because there it is. It's sitting there. It's a powerful technology. I'm a testimonial user because I used it in my software and it works. So anyway, what I'd like to tell you very quickly is my company is Stillwell Technology and Robotics. My dad's company was Stillwell Plumbing and Heating. I always liked that idea. I said, you know what? He put his name on everything. He was an honest businessman and he thrived and took care of his community. So I said, let's put our family name on it. Squad Leader is our team machine software built by university students, and it works. And I'm really proud of it. Next slide, please. Okay. Got just a little picture of agriculture there, and had a few videos. We've got a few tech difficulties on the web, but www.machineteams.com. I got plenty of videos for you there. You get the idea. If a farmer can go out, and if harvesters and trucks and mowers and planters and seeders can work together, if they can reshape what their area of responsibility is, if a high lift can pick something up and dump it into the truck because they each know where the other is and they're able to do complex physical tasks together, that's obviously quite powerful. Human on the loop means that you can stop the motion or you can adjust the motion. But autonomous, for my definition, means if you leave them alone, they'll do the task. Therefore, you need powerful decision engines. Therefore, you need traceability and auditability, because you know what? It's not the technology really that's holding us up. It's the legal network. It's the ability to survive a court challenge for hurting someone in a human-machine hybrid environment that really is the bottleneck. We could have autonomous cars. It's just hard to survive a court challenge when your car runs over someone and it was machine-driven. Well, if you talk to Tom and Helena, you will have a way through that. your revolutionary capability is here. I'm saying that with every bit of credibility I can give to you as an Army colonel and a aspiring roboticist who doesn't know a lot about robots, but my stuff works because I've got good proven technology underneath me. So I'm saying command and control of robotic systems that do physical tasks together as a beginning of all the things you could think of that you would want to do with that. Next slide, please. All right, a bit of a complex slide, but what I'd like to do is just illuminate, look, the software is capable of moving air, sea, ground, underground, underwater systems together simultaneously as long as you communicate. It makes sense, right? If you can give an object in a mass multiplayer online video game a command, then you can give it to a system. General Electric spent, I think, what, about $1 billion they're targeting on the Internet of Things. There are other ways to do it. And the gaming industry and our youth have the inside on this. And believe it or not, with peer-to-peer relationships, interoperability, and the things we've spent Army money on are already there. So I believe the architecture is already well developed. But we want disciplined, responsive, autonomous teams. We'd like to change healthcare in the sense that every geriatric nurse we meet has a bad back. Every wounded warrior nurse seems to have a bad back. So machines should be able to pick them up safely. Keel technology gives you accountability, gives you a forensic way to look back, because you have to be able to model the software based on human decision making. Then you must be able to give commands to the machines in your software. Then the software must make physical machinery work. There's 3 places that you have to decompose to do well in surviving a core challenge, but you had to build it anyway to be successful in the first place. But if you have auditable, traceable, forensically accountable software like Keel, then it's possible now. I believe that. I have quite a few things in the handout. Make sure you get one. I'm looking for partners. The sense I'm looking for partners is I need the ability to go take a revolutionary capability higher and willing to share. I'd really like the Department of Defense to have it. We're going to be commercial off the shelf, but I think this is I think a Ukrainian tank company with our software suddenly becomes competitive with a Russian tank company. I believe that with my whole heart. Next slide, please. One of the things that you see, it's a little bit fuzzy there, this is basic command and control software, but it detects all the physical robots in its area that are within. Right now we use Arduino, Robot C, we have XP1, XP2, we just went up to a higher wireless shield capability. Obviously there's a hardware component, but if you're detectable and if you will pay attention to C# and Robot C and Arduino type commands, then you can turn left, turn right, pick things up as a forklift, do team formation as a bulldozer. So if you can do it in the small, you can do it in the large. One of the things we've built in is a dynamic ability to add terrain and we're working on the ability to have discrete run-ahead simulation and off-platform cloud processing banks. So the ability to select multiple formations, the ability to select best decision engines. How many robots should be on the left? How many should be in the middle? How many should be on the right? How many people should be involved? How hazardous is it? How do you use reconnaissance sensors properly? How do you use apprehension capabilities and security? So you have to have, in my belief, an ability to look ahead and have a powerful, discrete simulation module to add to the validity of what you're doing. Squad Leader provides this and is growing stronger. If you look to the top left, that's a picture of 2 small robots picking up a cube together. They know where each other is by sensor. One is independent, the other one's dependent. Robot B knows what Robot A is doing and moves to help. Our next phase now, one will roll backwards while the other one rolls forward. If you think of it, it's a very sophisticated task, difficult. If you were moving a couch up the stairs in an apartment building over a weekend and you start to lose it and a third person walks by and says, oh, I'm just going to grab the corner, stabilize it, and we'll put it down. That's an incredibly, incredibly sophisticated team machine task. It is possible. So you have to be able to understand with sensors, awareness. So this is the kind of thing I think that we're building successfully. It opens the door to how many humans and how many machines should be working together. And that's where we're going with this software as well. Next slide. Okay, so we are continuing to build run-ahead discrete simulation modules. We are building a way for seamless communication envelopes to be extended by use of independent robotic systems that are under a hierarchy. We call it squad leader because if the human takes control of the lead robot, you take control of the whole system. So it has to be, you have to be able to grab the entire system and be accountable to humans. So it is hierarchical in a military sense. We're developing from simple threading to multi-threading to modularity and into true peer-to-peer architecture. So there will be something similar to HLA, but different. Similar in the sense, though, that there will be an industry standard that develops beyond what's just simply robot operating system. But you can see we need an interoperability capability for machines. And clumsily, I think we're trying to call it Internet of Things, but I don't think it has to be that clumsy. A little bumptious on my part, I know. Finally, we're going to build large teams of robots, and we're going to move up from little guys into larger commercial systems. So pretty soon we'll have forklifts, 50-ton bulldozers in formation. If you can do it in the small, you can do it in the large. It's just the risk is greater, right? So if you know a good insurance company, I need to know it. All right, so that's really, and obviously I'm a great cheerleader for Keel because I'm a satisfied customer. And if your CTO is truly a visionary, I don't know how they could look at Keel technology and not be very interested. And that's just from my small standpoint. So thank you very much. Any questions? And I'm shorter.